Great. Recording is in progress. Great. Now let me just quickly present my screen, and then you can let me know if it's visible. Yeah, it's visible. All righty, let's get started. So first of all, thank you all for turning up on a lovely Saturday morning for this vibe coding session. There are many things you could be doing today on a Saturday morning, but you chose to be here. So kudos to all of you for taking your time out and investing in learning something interesting and fun, something that's blowing up in the world as we speak, or in fact, that wave has started a long time back. But it's still very early days, right? A lot of us are still curious. A lot of us are still trying to figure out, hey, what can we do? And over the last year, I've been conducting multiple sessions on how do you use tools like vibe coding to go from ideas to prototypes to building actual products that you can put out to the market. And I think as I've done many of these sessions, there have been a lot of very common questions that I've encountered from folks. And usually these come from folks from usually a non-technical background because they have not spent time building software products. And then there's this magical device in front of us where it apparently just speaks in English and it understands and it just builds things for us. But then there's also a lot of fuzzy in-betweens. You start seeing stuff on LinkedIn saying someone made a product, they put it out on the internet, and then someone hacked into their system, their keys got stolen, and whatnot. Or you see a lot of memes around saying that, it's easy to vibe code, very difficult to debug. Then there are questions like, hey, can I build a complex business out of this? Can I build an enterprise use case? What can I do? What can I not do? So the purpose of today's session was to walk you through the fundamentals of vibe coding as I have understood it. I'm not endorsing and saying that this is the right way or the wrong way. This is how I have interpreted and how I have learned vibe coding and how I'm using it as well in the current startup that I'm building. A quick background to those of you who perhaps don't know me. I used to be building products at Myntra. I'm currently building my own startup. It's in the recruitment space, and the goal is to build an AI agent that can reason through resumes. Unlike screening, like if you have a really good hiring manager who actually understands the nitty-gritties of how to read a resume, understand what is factual, what are the actual skills and capabilities, what is signal, what is fluff. We're building that reasoning engine to go through resumes so that we can ensure that the right talent is identified and also making sure that they get visibility and we have the highest signal to noise ratio in the funnel. So that's what we're building these days. But apart from that, in order to keep myself also sharp in the domain of vibe coding, I do these sessions as well, because in classroom sessions like this, folks like you ask me a lot of interesting questions. And as they say, right, the best form of mastery is actually to teach people. So that's what I do as well on weekends. And with that, we will dive straight into today's goal, right? We'll be covering the fundamentals of vibe coding, and I'll be interjecting it with a couple of demos. And the purpose of these demos is actually to help you appreciate and understand the theory a little better, and also to see some of those nuances, what you need to pay attention to when you're vibe coding, right? So with that, we'll get started. So I think perhaps the very first question that a lot of us will have is that, hey, when we start vibe coding, there's just about every other startup building some vibe coding tool or the other. You have Lovable.dev, you have Bolt.new, you have Replit, you have V0 by Versa, you have Claude, you have Cursor, and there are probably another 10, 20 odd out there, each having its own audience. And what I would like to say is, at a surface level, many of these are fairly similar. There are nuances which differentiate them. So the goal is not to get overwhelmed by all of these tools. Honestly speaking, I would say experiment and try everything, right? It's a lot like picking a car. Right? There are so many different flavors of cars. Pick a car, find what excites you. But there are a few nuances as you want to start getting comfortable and start building products, right? So here I've tried to summarize probably what I think and what I've also validated with ChatGPT as to what each of these tools are really good at. So Lovable is really great for making a reasonable degree of MVPs, idea validations, a standard set of applications which have a front end, a little bit of a back end, a business logic, which you can put out there to the market. Replit also gives you a similar capability, but the ability to control the agent is a lot more powerful. So I personally lean towards Replit for many of the use cases that at least I try to experiment with. Then V0 Bolt, really great. V0, again, is by the folks who built Vercel. So it's great for a lot of front-end facing activities. So if you're building static website, dynamic websites, really great. Bolt as well, reasonably good on building MVPs, full stack applications. And the powerhouse or the workhorse of all of this is Cursor. It's what's used by software engineers. And as you start building, getting comfortable, I actually suggest folks to move also into the world of Cursor because it unlocks a lot of opportunities in terms of what you can do. It does look overwhelming, but I'll tell you why it becomes simpler as you start building the foundation, you start getting comfortable with lovable Replit V0. You will then start feeling comfortable as well to move into the world of Cursor. The only difference being lovable Replit V0 Bolt gives you infrastructure also to push the products that you've built so that it can go out to the real world. Cursor requires for you to connect it with other systems. You need to connect it to GitHub for hosting the code. You need to push it into Render, which is, think of it as AWS, but a lot simpler to use, which allows you to push and deploy your code and use it out in the real world. So there are a few other nuts and bolts that you need to connect Cursor with, but the kind of powers that it unlocks are really powerful. And today, it's probably one of the tools that I choose to use. But for the choice of today's discussion, to make it very simple and make it easy for all of you to get started, we're just going to focus on lovable, Replit, and Claude. The fun fact is Claude is actually the underlying tech infrastructure that actually powers all of these vibe coding agents. The reason being Claude is being trained on a lot of data very, very specific to programming and coding, and therefore the quality of outputs that I've at least personally seen coming out of Claude, which can be used directly, is a lot higher than most of the other LLMs. So you could definitely use ChatGPT as well to generate code. You can use Gemini as well. Personally, I found Claude to be a lot better when it comes to programming activities and getting off-the-shelf code, which can be reasonably well without having to break your head a lot, right? But again, I'm not saying that this is what you must do. Here's how I've thought about it, but I do encourage all of you to explore and try out all of these tools, at least to get a sense of what's going on all of them, and slowly start building familiarity, and then apply some of these principles that I teach you today to pick some of these tools and get started. The next question that usually starts is, well, now you have this wide open canvas. Where do I even start? For some of us, it's probably easy to get started, but for many, it's like, if you've never done this before, there are hundreds of questions running in your head. What can you do? What can you not do? Where can I even start? What is possible? And what can I even do, given the fact that I don't know programming? So rather than jumping into building, I think it's also important, in order to build a reasonably good foundation to get the max out of vibe coding, is to go through a little bit of basics of how most of internet software works, right? And for that purpose, I'm presenting you this very simple abstraction. This is a very standard diagram, nothing that I've come up with. I'm just using this to explain a concept, right? If you were to look at almost any internet software application, just focus on the following parts. You have an interface. This is usually your Chrome, or you have a website, or you have a mobile application, or you have some native software on your MacBooks, etc., where you primarily interact with the software and get your job done, right? And then there is an API gateway. Think of these as, the simplest example I could give for this is, if you're in a restaurant and you were to place an order, there's a server who takes your order and takes it to the chef and says, here's what needs to be done. Your API gateway is that. It takes orders from you to someone who does the logical work and brings it back to you, right? And then you have your application logic layer, where you define how your product should work. Why should it work a particular way? And almost any product, software product, at the end of the day, has some degree of data attached to it. So you have some place where you store information and retrieve information. This is probably the simplest abstraction that you should remember, because it helps you as you go deeper. And I'll show you with examples as to why this matters as well, right? So to illustrate, if you take, let's say, an e-commerce platform, don't get overwhelmed by the number of components. Just focus on the simple aspects. There is a front end where, let's say, take a product such as, say, Flipkart or Myntra or Amazon. You open up Amazon.com, you see a bunch of things on your screen. That's where your UX is, right? There is an API service which connects to a bunch of logic databases which pulls and says, hey, here are the products on sale today. What are the new products available? What is the price? What is the logic in which we rank? All of that is controlled by various logic. So you have something to show how your cart functions, how your checkout functions, how to collect payments, how do we manage inventory, how do we know who has placed an order, who's waiting in the queue. So each of this is governed by some kind of logic. And if you look at it, it boils back to the exact same abstraction. There's a client, there is some communication tool which connects between us and the software that does the job for us. And then there's a database in which all this information is stored. Let's look at another example. Uber, Lyft, Ola, on-demand cabs. Now, if you look at it, it looks very, very complex. But the highest level abstraction is you have a driver-side application, you have a rider-side application, and then you have a database in which all this information is stored. And then you have a bunch of services, right? How do you match a driver and a rider? How long does it take to get from point A to point B? What should be the pricing? What should be surge pricing? And you'll also use third-party services such as Stripe for payments. You'll probably use Google Maps for displaying the maps and mapping ETAs, etc. So you have a wide range of services. But again, if you remove all of the complexity, you land at exactly the same thing. You have a client side, you have an API which connects these services, then you have the logic which governs how your product should function, and you have a database in which all the information is stored and retrieved from, right? Now, when it comes to vibe coding, where it really helps is you can generate code which helps in building the front end, the user experience, and writing the logic. Plus, you can leverage APIs to connect these two services and also to databases and any other third-party service to perform actions. So you'll not be, per se, building APIs and databases. What you will be building is writing the code with Vibe tools to create the front-end experiences and the logic that governs how your software product should function. So, again, coming back, can we then vibe code an app like Uber, right? Because one of the things is when we especially come from a non-technical background, what we see is the software in front of us, and we don't understand the complexities of all that goes on behind the screen. So if you take an app like Uber, right, like I showed you in the previous diagram as well, there are so many different services which are running, which makes it fairly complex for folks who have not done any kind of programming in the past to be thinking of how this logic should function, how do we build it, etc. And for those reasons, I will give you a guideline as to how to think about scoping down your problem. But you will not be going about starting by thinking, can I build a company like Uber? Can I make a clone of Freshworks? Can I make a clone of Airbnb? When most of the YouTube videos go there, say, when I'm making a clone of Airbnb, what it's actually doing is just making a replica of the front-end website. Can I put the deck on full screen mode? Yes, but I need to keep toggling between screens for this demo. So I do need to keep it in this particular mode. It gives me greater control over actually moving between the deck and to the screens as well. But where possible, I will try to zoom into the screen, right? So most software products look very simple on the front, and it abstracts away a lot of complexity that goes on behind the screens. And as part of today's exercise as well is to show you a little of thinking as to how to identify what is simplicity versus complexity, and therefore avoid getting caught into the trap of what looks simple, but it's actually very complex. So a product like Uber has actually got a lot of complex business logics. Like, for example, how do you do fraud detection, maps, ETAs, like I said, search pricing, even sending out communications to multiple millions of riders and drivers at the same time. All of this is very complex logic, not so easy to build, right? And then there's the entire notion of architecture as well, right? In terms to say that how do you build software with certain constraints? Because ultimately, software does cost at the end of the day. It's not cheap. It's not free. You do have to host it somewhere. There are costs incurred in it. And also there are experiences, right? If let's say I was to make a request for a ride and I was only to get a connection tomorrow, nobody's going to use Uber. So there's a lot of complexities that goes into ensuring that those experiences can be handled really, really, really well. And therefore, when you put all of this into the picture, it becomes very difficult for vibe coding as a system to manage and solve for you, right? So there is a certain limitation called as context window limitation, which I'll come to in a bit, right? Now, it's great for people who build some degree of software. You have some intuition to know what you can do and what you cannot do and what you don't know. Here's where I, again, suggest that, use LLMs to your advantage. So here I say, anytime you embark on your journey of trying to build something, as a default, go to ChatGPT, Gemini, Claude, pick any of these LLMs and just ask them, hey, is this something I can do? For example, here's a question that I asked ChatGPT. I have no programming experience and I want to vibe code everything that Uber does to build a business similar to, and using a vibe coding tool like say Replit or Cursor. Is this feasible for someone like me? And what you notice is ChatGPT comes back with a similar feedback, right? The scope and complexity is incredibly large. It's very hard engineering problems. And again, you hit token context with limits. Now, what does this context window mean? So I'm trying to visually represent it. This is actually from Claude Cursor's website in itself. When you're trying to build software, what happens? Let's say when you typically write a message to ChatGPT, when you write a message, it gives a certain set of context as to what you are expecting as a user. Now, as you start going deeper and deeper, every subsequent previous interaction is also stored and summarized to a reasonable extent so that it understands why the next step should be done in a particular way and what it should reference to. And as your project starts becoming more and more complex, the amount of code that it has to store in memory, understand, parse, make sense to perform the next step starts reducing. So for example, when you use a tool like Cursor, you will see actually there's a small window where it says that how much tokens have been used. So for example, this is from one of the exercises that I was doing. I have used about 72% of my token window available to build my project. So what it means is if I'm not aware of this, as I get closer and closer towards the end, the amount of iterations that I do or problems that I can solve comes back to zero. And I have to find a newer way to start from scratch. And when we don't have too much of programming knowledge or we've never built software products, all of this is a black box. There is something that you've given us input. There's this magical set of things that are written in programming language. It's abstracted away from us and you see the end output. But we really don't know what to look at, where to look at, etc. So this does become a limitation. But even with these limitations, a lot of things that can be done. 200K tokens is actually not a very small quantity. It's actually pretty large. There's a lot of meaningful products that can be built. So don't be too worried about it, but still be aware of the fact that the fundamental premise, especially for folks who don't have a non-technical background, you are to a reasonable extent limited by this token window in terms of what the system can remember. Now, the difference for a programmer is their memory allows them to understand what each file does, what each logic does, and therefore they can choose to inject Cursor into very specific problem statements and solve for it in a very pointed opportunity. Therefore, they can use the 200K context window a lot more effectively and efficiently because they understand programming, they understand the file system, they understand what are the various systems that work together, they understand what each logic does, they can identify what breaks, they can choose selective parts of the file to be read and say, okay, why don't you try variation A here? So the amount of context that passes is also very limited, but the pointed action is also a lot easier. But again, for us, especially because we come from a non-technical background, it does becoming challenging because this entire thing is a black box. So let's keep in mind that context windows do matter. But again, don't worry. There are thousands of amazing products that you can still actually build and put into production with this boundary condition, right? To give you a simple example and to give you a little bit of excitement, you can actually build even V2's version of Airbnb, which was put out for the first set of users and customers. If you look, it has the ability to have profiles. There is a date concept. There's a map in which you can put in pins. There's a photograph, there's a sign-in, sign-up. So we can actually get to this if you build a reasonable degree of proficiency and say start using tools like Cursor, you can actually get to this stage. So it's not that limiting as well. And especially if, let's say, you're a founder, or let's say someone who's building a side project, this is actually very helpful because you want to first validate and put it out to a few 10, 20, 50 customers. You're not going to think of scaling out your product to thousands and millions of customers on day one. There are bigger problems that you'd face before that. Vibe coding only takes care of building software. What you'll realize is once you've built it, you'll face a new problem, which is marketing. It's easy to build now, but it's a lot more difficult to put your service out there, right? So you have those hurdles to face as well. But at least you're able to build a reasonably good V2 version of some of the products that you've at least seen commercially actually build traction in the market. And in case you're curious what a V1 looks like for Airbnb, it was a simple static website. So what I'm saying is you have plenty of opportunities to go to building something like a V1 of an Airbnb or V2 of an Airbnb comfortably, provided you learn some fundamentals, build some proficiency, and keep at it. At some point, you will start having the confidence and the ability to start building products that you can actually put out into the internet, such as this. Now comes an important concept, which is we have to understand the nature of this software that we're using, right? It's a lot like if you're trying to cook. If you don't understand how various ingredients function, you will end up putting chili powder in a cake, or you'll end up putting sugar in your biryani. Neither of this is a good recipe, right? Yes, you definitely know how to take it out of a package and throw it in, but at the end, it's definitely not consumable. So it becomes important for us to understand how do these vibe coding tools function, and how do you use that to your advantage to actually go about building. So this is probably a popular meme that some of you may have come across, but I'm going to use this as an opportunity to share it with those of you who haven't, right? Vibe coding is a lot like playing slot machines. How many of you have played a slot machine or gone to a casino? Don't worry, I'm not judging you at this point of time. I've done it as well for fun. But the premise of a slot machine is it's all on hope and luck. You put in a token and you pull down a lever, and then the reel spin. And if you hit a jackpot, which is like 3 items similar, you get a ton of money. Vibe coding is very similar to that in the sense that the effort required for you to give an instruction is so simple, and you just press this button called generate, and then something magical comes out. And at some point, you're like, wow, this is crazy. That's it. I've got the superpower. I can just go about doing anything. But it's also a little bit of an illusion, because the way it works is there's a lot of probability attached to the outcomes that come. So there are chances that 1 in n tries does actually give you a perfect bug-free application, and it works, and you're excited, and you get even more excited, and the chances are that you try something bigger and more complex, and then that could also work. But there's also the same problem with the addiction of slot machine. You may win small things every now and then, and eventually you start going to this very big problem statement, and then it just breaks apart, and you just don't know what to do, right? And I will show you a nuance, which is very important. Keep in mind this particular line. The casino is always in profit. Do understand that at the end of the day, these companies that are building these software tools are also profit-oriented companies. So there is a little bit of an interesting nuance that I'll show you as we go through these demos to say that if you're not mindful, sometimes it's very easy to slip down a very slippery slope. And before you know it, there's a massive hole that you've burnt in your pocket before even seeing something meaningful that you find, wow, actually it helps me, right? So what vibe coding has actually done, it has only reduced the need to know programming languages. Now, if you recall, one of the most interesting capabilities of LLMs is it's a language model. So what a language model does is it does translation between language A and language B really, really well. For example, if I speak in English, it can do a really good semantically, grammatically, colloquially correct translation to say Hindi or Tamil or Bengali or French. Programming is yet another language, so that translation works really well. However, what it does not do is it does not take away the need for understanding how software products work. So yes, there are some aspects where you can actually just give simple English language and you will see an output. And there are some limitations which I'll come to. But in order for you to truly, truly get the best out of it, it does necessitate for us to have a reasonable degree of understanding how software product works, and having that knowledge actually empowers you. So it may seem like a little bit of a small speed bump, but actually if you cross that hurdle, what it unlocks for you is a lot more. So that's what I'm going to emphasize, to understand a little bit about how software products work and how the nature of vibe coding tools work, right? And to demonstrate that, I'm going to show you a very, very simple example. It's called the program of Hello World. How many of you have heard of the Hello World program? If you've learned some degree of computer science, somewhere in school, college, etc., you would have come across this phrase called as Hello World, right? It is probably the introduction to software engineering for most people in the world. It's probably the very first thing that all of us is asked to do. And what it is to say that you ask a software to just display the phrase hello world. That's it. That's all there is to it. Nothing more to it, right? But here's where it gets interesting, right? And I'm going to show it in 2 dimensions. The first is if you were to do this on just a simple website, right? This is one way in which hello world could be written. This is the second way in which hello world could be written. This is the third way in which hello world can also be written. And this is the fourth way in which hello world can also be written. Now, don't worry for a moment what goes on behind the code. I'm just trying to show you that there are different flavors of the same goal that you want to achieve, each of which has its own variations, right? Now, I'll show you yet another dimension. Hello world again, but in 4 more different flavors. This is written in a programming language called Python. This is written in Java. This is written in C++. And this is written with HTML and JavaScript. Now, there's a reason why I'm trying to walk you through something as simple as hello world in all of these different flavors. Now, if you take a step back and look at large language models, the entire premise of it is it has been trained on an enormously large corpus of data, right? Data is the foundation upon which all of these language models work. And in this particular case, you will need to understand that there are tons of data sets available on the internet. So you would have GitHub, you would have Stack Overflow, there'll be someone's personal blog in which they've written about how to go about programming. A lot of these models have scraped the entirety of the internet. Plus, they've also got a lot of experts from various parts of the world who have written applications, software, code, etc. as examples. And they use this collectively through the transformer model to create, a model like, say, Claude, Sonnet 4, and then you have your ChatGPT, and then you have your Gemini 2.5, etc. So when you're making a request for a program such as Hello World, it has innumerable number of permutation combinations of what Hello World can actually possibly be, right? And therein comes the complication, right? And to demonstrate this, what I'm going to do is I'm actually going to show you what happens when you actually ask for Hello World in a vibe coding console. So I'm going to show you in a couple of tools. Sorry, one moment. Let me switch. Is my screen visible?
Yeah.
Awesome. One. Great. Now, let's just do something very simple here. This is Replit. So I'm just going to ask it to say, display hello world. I'm going to start this process off. I'm going to do the same thing with Lovable as well. Display hello world. So now both these tools are going about building it. So now notice something very interesting here, right? I've only asked it to display hello world. The way one of these vibe coding tools work, it's like a slightly over-enthusiastic software engineer. No offense meant. All software engineers are fantastic. In fact, at the end of this exercise, you'll realize how much more valuable they are in your life and how much of nonsense they have to deal with non-technical folks, product managers, designers, when you actually have to build software and the kind of challenge they undergo. But in this particular case, it's a very super enthusiastic software and says, hey, you know what? You asked for hello world. But no, I want to delight you. So what I'm going to do, I'm going to add a modern gradient background. I'm going to put subtle animation and hover effects. I'm going to make it responsive. I didn't ask for any of this. And therefore, you're going to get something in this process, right? Likewise, in this particular case, Replit has asked me to start with the design. Let's see what Replit does as well. All right, let's see if any of these. So one of the things that you'll slowly start building is patience with vibe coding tools. As it goes beyond Hello World, it takes a reasonable amount of time, but that's fine. So this is what we've got when we asked Hello World the first time around. So pay attention to everything there is on the screen. What I'm going to do is I'm just going to keep this open, and I'm going to create another tab. And I'm going to do the exact same thing. So let's go through this journey again and let's see what happens. Meanwhile, Replit is still taking its own sweet time. It's okay. It's better than us having to learn how to program, so it's perfectly fine. We give the exact same instruction, but look at what turned out. So on one side, we have this. On the other side, you have this. Exact same instruction, but very, very different outcomes. So this is what I was trying to help you understand, that because this is being trained on a wide range of models and it has so many permutation combinations, when you give a particular instruction, there is a directional sense in which you will get an output. So this was some previous tries as well that I did in case, on the off chance that they say the demo didn't work, right? So this is on Replit. You see two different variations. They look almost similar, but you can see that the font sizes are different, and you can see that the text copy is mildly different. With Lovable, again, you see very drastic differences, right? In terms of the text is exactly the same, but the UI element is a lot different in terms of the color scheme, the text and copy, etc. that's written. So the key takeaway from here is that for the same input prompts, you will get directionally correct outputs, but never the exact same output. This is not a bug. This is a core capability. And this is something that you'd want to actually use to your advantage. So you should be prepared to say that, anytime you give an input, chances are that it's never going to be exactly 100% of what you envision and imagine. It's going to be directionally there. But there are a couple of things that you can do to control it and get it closer and closer to what you actually want it to do, right? So let's use this as a capability to leverage what we want to build and not consider this as something faulty. But it is important to remember, and there's an important nuance we'll come to later on as well, right? Because if you notice, while we've asked it to only display hello world, it has gone over and above and done a lot of other things, right? It has introduced animations, it has introduced color gradients, it's added text and whatnot. And there are certain implications of this as the complexity of problem gets bigger and bigger. Now you'll ask me, hey, all fine, but we are not really here to build hello world applications, not going to get us anywhere. We really want to learn how to go out building some really slightly meaningful applications that I can build for myself or put out there and test, right? So what we're going to do is to understand how do we go from the world of hello world to slightly more complex applications. Now, before we go into demos, this is a very important nuance that I'd like for us to understand, because this sets up the pace to know how do you progress. It's a lot like saying that if you want to be the world's greatest cook, you don't invite 100 people and make a feast for them because you've never cooked in your life. Chances are that your meal for hundreds of people will go absolutely wrong, right? You've just learned how to boil water. At best, you've learned how to open the Maggie packet and keep it aside. Now, to progress from putting Maggie into boiling water and making Maggie to actually making at least one reasonable dish to a couple of reasonable dishes, there are a logical set of steps that we need to take, right? So to give you a simple example, if this is the hello world, and this is an example of a fun application that I built a while back, some of you may have seen it, that I put up on LinkedIn. It's a AI coach that I built to make sure that I get out of my chair and move around.
Steps? That's not a walk. That's a pathetic shuffle between your couch, fridge, and bathroom. Are you training for a nap marathon? Or just trying to see how close you can get to becoming a human paperweight? Your legs aren't broken, just your willpower. Get off your ass right now, walk out that door, and don't come back until you've tripled that sad excuse for movement. Move it.
So if you look at it, there's a lot of things that are going on behind the scene here. So one, it's an iOS app. Second, we're actually tapping into using Apple Health Kit's integration. Third, we're using OpenAI to actually come up with these kind of roasts and apply logic to it as well to say, what kind of roast should you give at various levels? So for example, if I walk less than 2,000 steps, what kind of feedback should I get? If I walk 2,000 to 4,000 steps, what kind of roasting should I get? Then we wanted to integrate voice as well, because reading is today not something that we all do. So as a lazy person, I want someone to scream at me. So I got a voice. So I got Whisper API to convert text to speech. Also, to do this really well, it can't be that it takes a minute for the speech to generate. It should happen within a few seconds of the app opening as well. And then having analytics integrated to see whether or not this product works, right? So to get to something even as meaningful as this, there's a lot of understanding that we need to know how to break down the journey from this simple hello world application to building an iOS application, at least of this nature, right? To understand this, I'm going to break this down using the first abstraction that we understood, right? All software components on the internet has these basics, right? You have your UI layer, you have your logic, you have your data, and your API. I'm going to explain what different complexities look for taking each of these components. For example, if you just take UI, what is simple to what is complex? Likewise, we're going to take logic and then go from what is simple to what is complex, then taking databases and then going from what is simple to complex. And therefore, you'll get a sense of, and also draw the lines to saying that, let's stop here. Let's not go beyond this, because beyond this, as a non-technical person, it does get very difficult. And I would request you to stay away from those realms. Exciting as it may be, if we have never run, we should not try to run against Usain Bolt. We should first learn to walk around our complex building. So when it comes to UI, I've broken down into 5 levels of complexity. The very first is, think of a very simple static website, right? It just displays text. It has images. There's not really much of an interaction. So think of, those old school 1990 blogs, early 2000s blogs, where you can just open up, you see a bunch of text, you see a bunch of images. It's not much you can do beyond scrolling and consuming that, right? That's probably the simplest. And Hello World is a simple version of that, right? The next step of that is single page interactive websites, whereas you can do some interactions. The layout changes if the screen changes. You have forms where you can make entry. For example, Google Forms, right? You have a question that it asks and you can give it an answer. You have buttons. You press it to make a submission. It takes you to another page, etc. Simple things that you can do. There are simple animations. For example, you can make a website a little glossy. For example, as you hover over a button, you can have a gradient effect to show that, hey, you can actually click on it. So these are some very simple things that you can do. The third level of complexity is to actually have many more of those pages interconnected. So you're talking about flows, you're talking about navigations, we're talking about real-time feedback as well. So for example, if I press a button, you want to get some kind of a response on the screen. You'd want to connect this to, let's say, an API can be done. In terms of mobile application, gestures, right? For example, scrolling, swiping, double tapping, etc. These are some simple things that you can do. You can also achieve products which have reasonable visual polish. So for example, your product doesn't have to look like a ugly wireframe. There is a certain degree of finesse as well that you can create, where it won't be world class, but at least it's not going to look ugly, right? It has a certain presentation layer to it. And there are a certain amount of 2D, 3D visuals as well that you can do. For example, using tools like, say, Replit, etc. Some reasonable degree of 3D modeling, which I'll also showcase if we have time permits, etc. What you would want to avoid getting into is what I call as rich interactive UI. Now, to give you an example, is take Figma or a Miro board, where multiple people are collaborating at the same time. That's fairly complex because it's lesser of the UI. The UI looks simple. There's a lot of intricacies that the front-end engine is actually trying to do behind the scene to make the real-time collaboration not possible, right? All of these applications today also consume a lot of memory. Now, I'll give you a simple example. Can you see here, as I hover over, how much memory my app is using? Right now, it's consuming about close to about 360 MB, right? And that's actually a pretty reasonable amount of memory, right? And if we're not aware of some of these nuances, what then happens is, let's say we're building a website, or let's say you're going to applications such as mobiles, it actually has performance issues. And what then happens is it becomes very clunky. So you may think your application can work, but even for the application to load, for you to click, becomes very difficult, and it may crash, right? This then becomes a lot harder. And then we're talking about applications or UIs where the UX is like top notch. Take Cred as an example. If you were to build the kind of animation detailing and the kind of effects that Cred puts into making its applications, fairly difficult to manage as well. And then the most complex of the lot is games. Like when I talk about games, I'm not talking about simple games, I'm talking about complex 2D, 3D games. So take example of something like an infinite Mario runner, or let's say a game like PUBG, or games which has physics elements. Like when you drop the ball, it has to replicate the real world physics. All of this becomes very complex. It has a lot of math and science that goes into the code, even on the front end, to render. And I would say you should try to avoid getting away from those kind of complexities. So there's a lot that can still be achieved within this scope of static website, single page interactive website, and multi-page interactive website. There's a lot that can be unlocked, especially for non-technical folks. Maybe as you start getting more and more confident, yes, feel free to go and explore. So none of what I'm saying is to say that please don't do it. I'm saying be cautious, be aware of these limitations, and don't try to, again, run against Usain Bolt when you have not walked out of your couch on day one. Slow and steady wins the race. The game has just started. Practice, build confidence, and as you start becoming slightly technically more comfortable, please do by all means go towards more complexities. The next, in terms of logic, here again, I've tried to break it down into a 5-scale system, right? The first is simple output only, what we saw with your hello world. There's nothing but you already hard-coded in the logic to say display a particular test. There's nothing you can do beyond that, right? So if someone were to open up that website, they can only see it, nothing else. So it's a consumption only, right? And in this place, you can display text, you can display images, you can probably put a few GIFs if need be as well. But there are certain limitations as to when it goes to, say, images and videos, that I would put at a slightly later state, right? And then you have simple logic controls. Now, the simplest example of logic control is calculator, 1 + 1, right? Now, it's not to say that's what you can do, but it's just to give an example of what a simple logic control is. There are other such similar kinds of simple logic controls. Conditions, greater than, less than, if X is greater than Y, do this. Recursions, that actually comes a little later. Basic states, for example, is the light bulb on or off, right? Has this particular state been reached by the user or not? These kind of simple yes-no questions, reasonable degree of if, then, else, those kind of logical functions are things that you need to practice, and these are things that you can achieve. And then the third level of complexity is where actually you starting to get real mileage. You can do what I call as CRUD operations. Now, the simplest explanation of CRUD is just about any software that you see on the internet is a CRUD application. What CRUD stands for is create, read, update, delete. It is a term for your database to say that you can create content that can be pushed into a database. You can read content from a database. You can go to a specific data element, update it, or you can delete it as well. You can perform all of these operations. And just about any application on the internet, your Facebook of the world, your Instagrams of the world, your Google Sheets, your Microsoft Word, ultimately are all CRUD-based applications, right? So there are a reasonable degree of CRUD-based applications that you can do. The second is you can start incorporating APIs as well, right? You can use Google Maps API, you can use a stock ticker API, you can use OpenAI, etc. And this enhances the power of your application. So some of these logics may not necessarily be sitting within your system. You can borrow some of these logics and leverage it to build applications. Or about that, you can also start thinking about going into slightly more complex algorithms, like sorting. Let's say sort from least expensive to most expensive. Searching for a particular keyword in a database, right? Maintaining the state of a user in multiple states. For example, a player could be playing a particular game and they could be in win state, lose state, or somewhere in between that you want to keep a track of. So you can keep a sense of what those are and achieve those kind of outcomes as well. And then, like I said, you can use APIs to leverage someone else's intelligence and a lot of powerful logic, which you can just consume and use in your application, either through a front end or with lightweight logic at the end of the day, right? Then comes scale, latency, cost, hard problem. This is what I call as, enterprise application building. This is architectures, complex database choices, more complex algorithms which are more efficient from a speed point of view or from a cost point of view. Managing problem statements such as concurrencies. For example, right now we're on Google Hangouts Meet. There is an incredible amount of software that is going to ensure that all of us, close about, let's say, 62 of us are having this conversation in real time, seamlessly, without this system falling apart, right? Making sure the system is fault tolerant. All of this is very, very complex. So the minute you start going into these realms, stay far away from it. This is the realm of our friends, our computer science friends. Let them solve it for us. If you need, get them on board to solve some problems, but stay far away from them, because this is a realm that unless you have learned computer science, it becomes very, very difficult to go and even understand what needs to be done in the first place and do it in the right, reasonable way. And then comes the last complexity, which is AI. If you're thinking of building, say, a grounds up model or doing machine learning, forget it. Not going to happen, right? You need to learn another set of skills, which is data science, etc. Right? So stay far, far away from this problem. But it's not to say you can't use AI. You can consume them via APIs. For example, you can use Google Vertex, which will give you access to, say, Nano Banana. So you can actually make a cool image filter with Nano Banana, but without having to build Nano Banana. You can consume it as an API and solve the problem still. So long as it's abstracted to an API-based access, great. But if you're thinking of AI problem statements, do understand that we have not even learned how to do 1 + 1. Going on to predicting what will come and what can be generated is a fairly hard problem. So I think one of the key important takeaways of this entire session is also to be grounded and not be too egoistic to say, oh, I can go solving anything. Know what you don't know, right? One of the biggest problems is we have insane aspirations without fundamentally understanding what we can and cannot do. And that sets us up for failure from day one. Rather, if you treat this as a long game and say that, hey, I don't actually know programming. So when I don't know programming, I shouldn't try to go aim for building the next Tesla or the next OpenAI. I should start with what I can do rather simply. So do not let your ego take control of you. Slightly philosophical, but absolutely necessary in order to get the best of what you want to do with this tool, right? The last part of it, not the last, the second last part of it is the database angle, right? In databases as well, there's a lot of layers of complexity, starting with no database. If you can actually build applications which don't involve database, that's probably the best place to start from, right? Because there are certain challenges when it comes to databases. Even something as simple as an API integration, for someone who's not done that, is actually a little bit of a tricky problem. It's not to say you can't do it, you can do it, but start by doing things which do not have a database. There are plenty of things you can do that as well, right? From there, progress to a simple database, right? This involves having a single table to say that, for example, you're building a to-do list and you're just saying, hey, here are the tasks that I want to do. That's it. There's only task, nothing else, nothing more complex than that. Simple relationships. You can say that for a particular task, there's a cost associated. You can probably have two tables and you can show the relationship between the two. You can think about simple storage functions where you can upload images, video files, audio files, and get them to be played back. And that's where I would say we need to stop. Anything more becomes slightly more complex, because as you start having more and more tables, it becomes very difficult to connect the databases together make reasonable logic to interpret between them, and to ensure that you're managing those tables. So as you start going towards hundreds of entries, thousands of entries, maybe more, it becomes difficult to write, read, and that does create certain limitations if you're not technically proficient. So it's not to say you shouldn't try going that, try, but know that these are slightly more complex problem statements. And then there are problem statements which involve unstructured data, where you're storing, let's say, a large amount of text file and trying to pass through it, etc. Slightly more complex problem statements. And then there is the aspect of data safety and reliability. In order for good software to work really well, there's a lot of good database practices. Like, for example, you would want to have multiple databases to store the same information. So the off chance that for some reason you screw up with one database, there's something else as a safeguard. So there are practices which ensure that information is stored in two different systems, ensuring that even one system fails, there's another system that takes care of it. And these are scale problems. So by default, if you're going into problems which have scale and which looks large, use that as the first high-level intuition filter to say, that's not really required for me right now. I have not even built a product that is being used by 3 people. I'm not even talking 10 people, 3 people. Don't think about hundreds and thousands of people, right? That's where, again, you're trying to jump the gun before building basic foundations. Then comes even more complex problems when it databases, right? When we're talking about retrieving data information from thousands of tables in real time. For example, think of Google or Instagram, where the minute I open up the app, you have this massive newsfeed that comes in. There is a lot of magic that goes on behind the scenes in terms of managing the databases, the logic those goes into figuring out what are the right algorithms to show you the right content, and all of that being delivered to you in a few seconds, right? So anytime we're going into those kind of problem statements as well, stay away from it. Then there are problem statements which require a different style of databases. So simple databases, you write text. Then there are graph databases which are more relational nature, like how Facebook has built, and to show the relationship between 2 entities and what can be done as a consequence, etc. And then you have more advanced, complex data stores such as data lakes, where you just dump a large amount of data to be processed later. Vector databases, a very hot topic today when we're talking about LLMs, where you use vector databases to store large language model input data for doing your fine tuning. If you've never done basic databases, don't even think of going towards vector databases. Stay away from it, right? After you build, your comfort, etc., with probably the help of some technical person by your side, yes, try seeing what a vector database is extra. But before you've got your basics right, jumping to vector databases, etc., is an inordinate leap of faith and a recipe for disaster as well. Lastly, coming to APIs, the easiest is no API. Life is simple. But you want to go a little more adventurous? Yes, we should. It's the case of making a simple case of request for data and get it back. For example, there's information in my database saying, pull me back Deepak's date of birth. Simple. Comes. No questions asked. Slightly more easier. Then comes slightly more complex applications. Like, for example, you want to build an authentication system. Basic requirement for a lot of use cases where you want to put it out for at least 2 to 3 different users. You want users to create an account, make sure their password is secure. There is a certain sort of practice to ensure that, you're not exposing the user's password in your API so that anyone can read it, right? Or you're making a request for a payment, and that request is so vulnerable that somebody else can hijack it and do a bunch of activities as well. So you can do certain degree of these kind of activities, but beyond that is where complexity starts. For example, API is where you're trying to do event listening, right? As you're performing an action, you want to get probably real-time data that's coming in for you to perform certain kinds of actions. You'd want to stay away from that. So you can integrate APIs into your analytics, which does all of that for you. But for you to be going down and trying to build, manage, orchestrate those kind of things can start getting tricky. And lastly, trained software engineers would probably use Cursor to even write code for building APIs. You would not want to think about even building APIs at this point of time. Learn to build simple internet software. Don't try to get into building APIs as a use case as well, right? So this should broadly give you a high-level overview to say where is a nice safe space, and within this itself there are a ton of things you can do, right? I can guarantee you that. But don't try to go beyond this at this point of time, because it sounds exciting, but it's a recipe for disaster. But if you're going to say, hey, this was great, but I want to see with a little more examples of what this looks like a little more methodically, Don't worry, I have that covered as well. So here's what I have is what I call as a step-by-step roadmap. In fact, I have a workshop that's coming up next week where I actually will walk some of you through this exact 17-step process where you will go step by step getting proficiency in each of this. So you start with something as simple as a text display and do something like a hello world. From there, you try to play around and say, hey, can I create variations of hello world? From there, you learn the proficiency of learning to do a simple 1 or 2 feature-based website. So build something like a simple calculator and try to create different permutation combinations of calculators. Once you build that confidence, you say, oh, right, let's go a little more complex. You start by building a to-do list. And instead of using a database, we use something called a JSON storage. Don't worry about the technicalities. It means you don't have to use a database. Without a database, you have a database. That's the magic, right? So you build something as simple as that and learn how to make inputs and get outputs. Once you build that confidence, you'll say, hey, let me make this data persistent. Let me put it into a database. So how do you then connect it to a database and build confidence to know what does it take to connect the front-end application to a database, store information, retrieve it. Once you've learned that, you want to start manipulating data in your database. You would want to do update actions. For example, if I've made a to-do list, I'd add a description and then say, go back and add additional description to it. Can I do those kind of operations? Can I delete entries and be very specific about the entries that I want to delete? Rather than deleting the entire database, you're saying, I only want to delete line item X and have control over that, right? So the key why we're doing it in this methodical step is to gain control. That's the most essential thing. You can do many things without control, but to build control, you do these things in a step-by-step fashion to understand what kind of instructions to give. How do you respond to things when they don't work? How does your input prompt actually result in the kind of outputs that you want? And slowly start building proficiency to a point where you then start saying, hey, let me start doing user authentication. Let's create accounts. Let's start pulling data from APIs. For example, let's build a stock app where you can build information from various news sites and show what is the latest news for a given stock. You then want to go into building a little of confidence saying, hey, I'm doing this with Replit, but can I go beyond that and start using tools like Cursor and have my own deployment environment? What kind of benefits do I come out of that? That allows you to unlock newer capabilities. For example, how do you build search functionality? How do you start using file and media handling? For example, uploading images and videos, playing back videos, storing those videos without any kind of issues, playing them back without any kind of latency issues, etc. Adding analytics, integrating payments, because as you see, then you're starting to build the foundation to start putting all of these things. But as you notice, I'm not trying to jump to level 100. I'm doing this in a very, very step-by-step fashion. And that builds confidence. And also what it does is it reduces the amount of risk from hundreds of other elements. One piece, one problem, simple resolution. Then gradually building up the confidence to build mobile apps. And even then, we'll not jump to building most complex apps. In fact, we'll take mobile apps and start again from ground zero. We'll say, start by doing a simple hello world. Start from that to control text, because the mobile is a different beast altogether. You want to learn how to control the mobile environment. Once you've done that, you can start exploring things like cross-platform applications. For example, you have, let's say, an application like Notion, where the content is visible on a website and on your mobile app. And when you're doing actions on your mobile app, you can also see that reflect on your website. So that then makes it a lot more fun, because the kind of use cases that it unlocks becomes a lot more. Then comes even more interesting use cases where you can scrape data from the internet. For example, the products such as OpenAI, Claude, etc., they're built on the premise of scraping the internet. So how do you then scrape unstructured data, converting them to structured data, and then finally going on to, let's say, things like native device capabilities, accessing the camera, accessing Apple's HealthKit tools, using that to create mishmashes of use cases. So this is how I typically tend to progress, and this is what I try to teach in my longer course as well. Feel free to take screenshots of this as well and try this. But this is a more step-by-step method, because the goal here is to build confidence over time. It's not to say that I will become Usain Bolt, but if I keep doing this repeatedly, I have the confidence to systematically learn the skills necessary to going on to building more complex applications. Now, by this time, you'd be like, guys, I came for live demos. There's too much of theory. Let's get to a little bit of demos as well. And these are demos that will help us learn. It's just not pure theory now. We'll build something. And in that process, learn what comes out of it. Right? So what we're going to do is we're going to wipe code an expense tracker for a single person. All right. Now, there are two ways of doing this. Method one is pure wipe coding. Just like how it's a display hello world, you can say create an expense tracker for a single person. To save time, because each of these iterations sometimes takes 20 minutes, 30 minutes, and I know that a lot of those people won't have patience to wait for 30 minutes for the screen to show something. I already have a pre-built version. So what I've asked is a very simple instruction. You can notice in it, create an expense tracker for a single person. That's it. That's all the input that I've given. And lo and behold, give it a little bit of time for the page to load. Voila, you have this. Now, at this point, all of us will ideally go, wow, because all I said was build an expense tracker. And look at all the things that has come out. That's total expenses. What is it for this month? Top categories. This week, you have a field to enter, categories, description, date picker, adding the ability to put in expenses, filters, and whole bunch of records on what are my expenses. Now, at this point, all of us should be going, wow, this is amazing. Right? And this is exactly the reason why all of us are going crazy about vibe coding. The sheer ability for us to just give this very simple instruction and to get something as magical as this. But it also has limits. And that's what I want to emphasize on. When you start doing zero shots, as I've shown you, which is giving very little context and instruction, to few shots giving one or two instructions, it definitely allows you to build what has already been trained on. So, for example, something like a personal expense tracker or wide range of softwares, there's a reasonable number of such applications built, trained upon. So it just builds a variant of it and gives it out there. But what it's taking away from you in this process is the ability to create net new things. And that's one of the superpowers that you'd want to learn with vibe coding. It's not to be able to do what is already out there, right? It's also for you to explore your creativity, and you may have some brand new ideas for which there's absolutely no solution out there. That's what you really want to unlock with vibe coding, the ability for you to imagine something brand new. It just does not exist. But to get to that, you need to learn a couple of new skills. You could try doing a zero shot. There are some limitations, but when you learn a slightly new, different technique, it allows you to build these products a lot more effectively, and the range of such products then start expanding, right? The second big reason, and you would have seen a lot of memes about this, is it becomes harder and harder to debug as the complexity increases. So as you can see, when you ask to build an expense tracker, sure, you got this. But then you'll start asking it to add more and more such complexities. And at some point, you'll start getting something which becomes slightly unmanageable in terms of when an error happens. You just don't know where to go and look at to solve the problems. And that just stops your entire process. So we won. Something great come out, you were very excited, and then you said, oh, let me add 10 other things to it. And suddenly 10 more things got added up, and then suddenly 10 plus 10 did not give you a working product. It gave you something very buggy and something difficult for you to use. And you just don't know what to do with it. So debugging then becomes very difficult as well, right? So as you start building towards more complex zero-shot applications, the number of features increase, and therefore the errors can also increase. And again, if you're a non-technical person, it does create it. However, for technical folks, it's actually a lot easier because they can understand the logic, they can understand the file structure, they can go into very specific parts to say, if the error is happening here, this is most likely the reason, and they can just narrow down into it and solve those bugs easier. But for non-technical people, like I said, it's a magic black box. What goes on inside it, we don't know. We just see the output. So in order for us to solve for those debugging issues, it does become important to learn a slightly different new skill. It seems like a roundabout process, but actually it gives you a lot of leverage, even to go back to doing zero shotting as well. And there's one last reason, and which is one of the topics that I talked about earlier on, which nobody talks about, is when you give full access control to doing zero or few shots, it drains your credit like crazy. For example, one of the things that I was experimenting a while back was to build a version of Word. Now, there are two ways I did. One is I built it grounds up by myself. The second was to zero shot it. But to go from zero shot to an actual working model, it actually drained about $5 of credit. Now, think about it. It literally in about 30-minute session, in a 35-minute session, it drained about 1/5 of my credits for the entire month, and it still doesn't work. That's the irony of all of this, right? It's still trying and it's going around in loops. It's going around in loops trying to figure out what's to fix, right? So as you start picking up more and more complex products, it does becoming a little challenging for debugging. And I do feel sometimes that, again, at the end of the day, a lot of these companies are for-profit companies. And if you go into the research of how the economics of this works, I'm getting subsidized tokens from Claude. I'm further subsidizing these tokens and selling it to you. And therefore, I need to make profits. And if I make zero shorting and few shorting easier, you actually don't know what's going on. What you're saying is I've given an instruction, somehow some magic happens. But behind the magic is there's a lot of possible unnecessary nonsense, which you can actually solve easier if you learn a little bit of the fundamentals and get to your end outcomes without spending 35 minutes to actually for it to still go in a loop and not know what to do next, and draining out a significant portion of your credits. So if you buy, say, a tool like Replit, at least in the earlier version, you can buy additional credits. Now they've capped that as well to say that you can only consume $25 a month, and we can maximum give you grace credit, and you have to wait till your next month. So, which means there's this now new forcing function that has come in, which kind of also restricts the amount of freedom that we have. And if we go down this path of uncontrolled zero short, few short usage, your credits will disappear. Chances are that once in a while it does work, but that hooks you on to trying it out. But then at some point you start going towards a lot of wastage as well. So learning a little bit of the fundamentals to achieving the same goal and not trying to relinquish too much control to your vibe coding agent also allows you to, like I said, greater expanse of things that you can do. Second, you can do it faster and more importantly, cheaper, and debugging becomes a lot easier. So now what we're going to do is, instead of vibe coding it and just saying that, hey, build me a personal tracker, we're actually going to do it a little more step by step. But this time, we're going to do it slightly differently. And for that, I'm going to introduce a new skill. If we have to build something like the expense tracker, in order for us to know even what goes into it, we need to know how does an expense tracker work. We need to define its functionalities, right? If we don't know what an expense tracker is in the first place, what should it do? What should it not do? How should it work for me? You're just hoping for magic at this point of time, right? So it does become important for us to start writing the functionalities. I'm going to give you a very simple framework for doing it. And again, we're going to bring back our friendly high-level abstraction. All software applications, if you were to use the simple framework, it allows us to also write the requirements easier. So if you recall, you have a client-side component or the UI, you have the application layer logic, and you have the database. Now, to do this, I want you now to actively participate and tell me, if you were to build a single person expense tracker, the simplest version, don't try to complicate it. Dumb it down so that you get the first version to come out. What are the essential elements that go into the UI? What are the essential elements that constitute the logic? And what goes into the data? So feel free to type it out in the chat, because if maybe I open up the mic, everyone starts speaking at the same time. So what you can do otherwise is you can raise your hand and I'll tell you who can open up the mic to speak. So that may be faster. So raise your hands, and I'd like for you to suggest simple single person application tracker. What is the UI element? Let's maybe just start with that. Don't even go to logic, don't even go to data for a moment. Just raise your hand. I'm talking about the UI element. Think about it. Think about all the expense trackers that you've seen. What do you need? All right, I'm seeing date, amount, category, all right, amount, add expense, view overall status, UI, expense category, text, filters. Got it. Interesting. Now, let's go to the next step, logic. Tell me, what are the basic logic that is required for a simple expense tracker? Logic, sort, add, group by category, all right. Sort expenses by category. Again, sorting is, we're jumping the gun. Let's simplify it even further. We have not even built the basic. Sorting can come a little later. Nimisha is saying input, enter amount, sum to show at the end of the month. All right. Keshav, please mute yourself. Right. Sum by week. Great. All of this is interesting, but I'm gonna make it a little simpler for us, right? See, what's happening again is we're almost often jumping and going to greater complexity. The most simplest version of an expense tracker for a single person, even before adding category, filter, etc., is the simple ability to select the date, add an expense description, and entering the amount associated. That's it. That's simplicity here, right? Everything else is you're adding more and more complexities, right? And the UI is you need a UI element for picking the calendar date. You want a form field to enter the text expense. You want a form field specifically for numbers, and you want a button to create new entries. That's it. Nothing more. Don't even go to sorting. Don't even go to categories. Because again, what you're doing is, if you notice through this example, is we're jumping to level 3, level 4 before even building an even more simpler version. Our goal is to start making things simple, not complex. So one of the key skills that we have to rather unlearn is to go away from complexity to simplicity and try to understand what is the fundamental unit of this product. What is the base? Everything else comes on. Like, for example, you can only sort after you've got entries. You can only categorize only after having entries. If you're trying to think of categories and sort, you don't even have entries at this point in time. What will you sort and categorize, right? So the key is to think in terms of tiny building blocks and identify the sequencing and to find out the smallest version that you can build. In this particular case, we don't need anything more than a simple calendar picker. We need a form field to enter the text for the description, a form field to write the numbers, button, and the logic for entering those values and saving it to the database. That's it. Everything else is an overkill at this point in time. Because if we have not even done this, everything else is only going to add to more complexity to figure out, is the logic working, is the sort function working, is the grouping working, etc. Right? So you want to start simple. So again, anytime you think of a problem, try to list down all of the functionalities associated with and start from asking the inverted question: what is the absolute bare minimum, simplest atomic unit of this product? The most bare minimum, like without it, nothing will. For example, for a product like Twitter, the most fundamental unit is the tweet, which is the ability to create a tweet. If I can't create a tweet, you can't do anything else around it. You can't connect friends, you can't create users, nothing else matters, right? Say, take an application like Spotify streaming music. If I can't upload a single audio file and play it back, everything else is useless. What is the point of playlist? What is the point of a user, the interface for showing the image? Nothing. If I can't upload an audio file, press play, and it doesn't play back, everything else breaks. So you need to learn the importance of stripping down any idea that you get to its absolute bare minimum. Now, the only caveat I have to say to it is, we will not reach this level of proficiency of day one. It takes practice. To be honest, when I used to start building software products maybe about 15 years ago, my first version would have 200 features in it. So we all go through this hyper excitement, complexity phase, and we learn through innumerable number of battle scars that it's easier and more effective to figure out what is the simplest version and then gradually add layers of complexity. So now, we're not going to spend time theorizing it. Let's actually go about building this. Alrighty, is my screen visible? Great. So now, we've listed down the UI elements. We've listed down logic. What do you think I should give as the first instruction here? You can write it out or raise your hand and tell me what you think we should ask. I want a very specific instruction to tell Replit what it should build for us. Got it. The tracing paste, those 3 points of view, UI, logic, and data. Understood. Anyone else have a different point of view? Got it. Some very interesting suggestions. So here's how I approach this, right? Given that I've made a hello world, assuming that's where I'm starting from, and this is the next application I'm trying to build. The first thing I want to understand is, can I do something as simple as an input output? If I have not understood how input output works, everything else is moot point at this point of time. So what I'm going to do is say, I want, or rather, make a simple text field where I can write a description and it is back. Do not add any other elements apart from this. That's it. Because right now, I've just conquered hello world. I want to progress to seeing if I can give an input, can it display back? So previously, we hard-coded hello world. Now we are displaying text from the front end. So we're giving an input through the client side and displaying it back in the UI. So we want to see whether that works for us. So as you can see, all of us in the text, in the chatbot or chat room, right? We're almost jumping to, again, trying to add all complexities in one go, right? Add a date picker, add calendar. This is great. It's not to say the system will not take this as input, but again, we're learning the art of step-by-step building so that we have control over what we're building, because this control allows for us to have the practice to build more complex products as we progress. If we start clubbing things together, the fundamental problem is if one of these goes wrong, you will not know which went wrong. So to have control over what goes wrong, and in the off chance one of this element fails, you only know this was the latest increment that was done. So it's easy to go back and say this was the only step that I changed. That step failed, so let's only debug that. If you add 3, 4, 5 elements and it fails, you don't know which one failed, and therefore it becomes difficult to understand what you should do to fix it, right? Let's understand that we are treating with a black box here. Everything is happening behind the screens. Difficult for us to make sense of what's going on. So the easiest way to solve for that problem is pick it step by step. And the key is therefore start by going towards the simplest version. Now you'll be like, Deepak, this is too much of a time waste, man. Like I just want to vibe code it. Sure, you can. But again, understand that at some point, we have to understand our own limitations. If we don't play to our limitations will end up being a bigger roadblock a little quicker than we anticipate. So helping build these fundamentals unlocks a lot more power, right? In the early days, I also used to do a lot of zero shot. And then I realized that, oh, wow, like I'm really, really hitting a roadblock. I can't. So let's put it this way. I've burnt enough credits to have reached a state to say, here's how we can do it in a slightly more effective, easier, with greater control and unlocking creativity for us. So now let's wait patiently for it to create this very, very simple version. One of the other interesting side effects that will happen is in case you're working with tech teams, you're from the business team or the design team, and you keep going to your engineering team saying, guys, I asked for this yesterday, and it's still not done. At least you'll now start building the appreciation to understand how challenging it is. Even an AI takes time. So you'll be nicer and kinder to your engineering counterparts, and you'll at least understand and empathize with them. So they'll become greater friends with you after doing this white coding exercise. Awesome. So now Replit is it's taking his own sweet time. It's okay. Finally, it gives us exactly what we want. So I'm going to write, hey, folks, this works. Cool. So now we have unlocked input output. So now we know that we're able to get exactly what we want. Nothing more, nothing less. We wanted a field for input, we've got that. We wanted a field for output, we've achieved that. Great. Now, what is the next thing we want to add? Again, use the same thinking process that I did. We stripped it down to just a simple text box. There are two more elements left. We have a date picker, and then we have a numerical field, and then we have a button that needs to be added. Which one do we pick? Feel free to pick. Name of the app. Don't worry about the name of the app. You can name it whatever you want at this point of time. That's really not the biggest blocker at this point of time. Add a number and display. Chalo, let's do that. Let us add a form field to accept only numbers. We are converting this into a simple expense tracker. So now what we're doing is also priming and giving some context, but yet trying to retain control. So pay attention to how we're saying that, right? We're saying that adding a form field to accept only numbers. We're also giving the context saying that we're now converting the simple text description system into actually more of an expense tracker. But we've said add a form field to accept only numbers. Now, if you give this vague instruction, it's not going to know where to introduce. It can introduce it on top here, it can introduce it left here, to the right here, to the bottom here, somewhere here as well. So we want to be very specific. So we're going to say, make this form field to be on the right-hand side of the text description. So let this start building out. All righty. Food expenses. And here, technically, we should only be able to enter numbers. So, for example, if I'm writing letters, it's not getting captured. So, fantastic. But let's say enter a number 30. Great, it's coming. So now we've been able to control and allow text plus numbers to be written here. We've created a form field specifically to capture numbers, and we're able to display it. So great. We have now been able to control this element as well. Now, any expense tracker at the end of the day has to map back to a date. So we're going to add the date element as well. Add a date picker to the left-hand side of the text description box. I see there are a couple of questions in the chat. I'll try to answer these questions towards the end of the session. Yes, so we need to think of it as giving instructions to a 4-year-old. That's a really good way to put it. But think of this as a genius 4-year-old who can actually do things for you. No offense to 4-year-olds. I was a 4-year-old also once at one time. But this kid, yes, is capable of programming, building some great things. But I would rather say the other way of framing it is, if you were to talk to a great engineer will ask for specificities. If you go tell the engineer, build me an app, he'll like, what do you want? Like, what is this app about? What should it do? If you say, hey, build me an e-commerce app, they'll come back with asking you questions. So I would rather reframe it and say that if you are talking to a very intelligent engineer who cares about what you're building, they will want to get into the specificities. And that requires for you to be specific about what you want as well. So articulating your specificity, breaking down into tiny chunks and explaining what each should do and the way they work is essential. For those of you who probably are from the world of product management, you'll relate this back to the act of writing a product requirement document, right? Where you get into the nitty-gritties of writing. You don't just say, we think this is a great business case, go build it. You say, what's the components, how should each component work, what is the right way of doing it, what is the wrong way of doing it, etc. So it does then become important to start getting into the specificities. So now we've got a little bit of a date picker as well. So fantastic. So we've got the date, food from Zomato. Great. So now we've been able to get the date, we've got the input, and we've got the number as well. Now we want to add some more stuff. We want to add more entries. So we need to have some place where we can enter the input as well for that. So add a button to create a new row of entries consisting of the date, the description, and the amount. Each new entry should go in the row below. The button should be on the top left hand. Look at the amount of specificity I'm getting into, because otherwise, if we just say add a button, where will it add a button? Left, right, top, center, what should it do? Has no clue. But now we're specifying the functionality of this button. When you say add a button, what should it do? Create a new row of entries. What should it consist of? It should consist of your date, your description, and the amount. Where should it display? One row below. So this allows for us to control. And again, the reason why we're doing this in a very step-by-step fashion is to learn the art of controlling the system, getting it to specifically to create what it wants. Now, this one, you'll say that, hey, you know what? The UI looks ugly. Not a problem. Once your logic starts working, you can start polishing that as well, right? What we're learning is the act of controlling the system and to give it exactly what we want and not to run wild. The wild is nice when you're just doing things for fun. But at some point, when you are getting a little serious about what you want to build and get to very specific outcomes, you'd want to have as much control of it as possible, right? So now you see there's the button on the top left. And now let's do one thing. Let's enter a date, food expenses, 1,000, add an entry. And now you see, when we do it, it failed. Now, this is exactly why it becomes important for us to write it step by step. Because now, the only thing different we've done is adding the entry piece. This was working, this was working, this was working. The new element was adding the entry. Right now, at least it becomes easy for us to backtrack and say, okay, adding the entry is the issue. So we can go back and saying that when I click on the add entry button, it is not adding a new row below the very first row of date, description, and amount. So again, if you notice, this is kind of how, if you were, let's say, working with an engineering team as well, you give very specific instructions for debugging. You not go and say, app is not working. You'll say, hey, I tried the app, I click this button. The ideal behavior is when I click this button, this should happen. The date picker should come below it. Another line of description, another line of amount should be created. But that's not happening. So you're having a similar conversation with your agent. Rowan's asking, if I provide the context that I'm building an expense tracker at the start and share feature specifications step by step, will having this extra context change its behavior? It helps to a reasonable extent. So it has a directional sense of where you're going, but you also have the control to say this is the exact steps that you need to take and not overstep it. Otherwise, if you just give it expense tracker, the area of divergence is huge, but expense tracker gives it some context to say, okay, this unit is looking in this particular direction, but they want to stop here. So it doesn't go beyond that and add 5, 6, 10 other elements, which makes it complex, but it gets a rough idea of what are the intricacies and connections. So you're priming it up. So it's actually a good practice that you can start using it later once you've learned some of these basics. Cool. Cool. So now you see that when you've added an entry and you put it in, you've got entry 1 going in, entry 2 going in, and it's going line by line into the system. So now you have got greater control. So with this, it unlocks opportunity for you to do a specific set of activities and ensure that, if suppose one incremental element that you add is where the system broke, you don't have to worry about everything else. You can just focus on this specific capability. And one of the interesting things in, say, a tool like Replit is there is this activity called as rollback here. For those of you who have probably heard of, say, tools like, say, GitHub, there's something called as version control. It's a lot like, let's say, when you write drafts, email drafts, you'll write version 1, and then you'll create another document to create version 2. Then you'll create another version after some iterations to create version 3. It creates a history. And in the off chance that something about version 2 was not right with that to version 3, you can always throw away version 3 and go back to version 2, right? This is an equivalent capability. So some of the tools like, say, Replit, etc., have this inbuilt, which allows you to roll back to the point which worked. Because sometimes what can happen is, sorry, 1 second. I think some folks are trying to enter. All right, sorry. Okay, no one. What can happen is, sorry, I lost my train of thoughts here, right? So when you're trying to build more and more complex projects, and when you do get stuck at a particular point, this rollback allows you to say, forget this newer version that I've tried to build, this incremental capability. Let's go back to testing whether the original functionality worked, and that de-risks your entire project. Otherwise, imagine having to throw away everything that you've built and not having something where, let's say, 3 out of 4 things work. Rather than throwing away all those 3 things, at least you have 3 things that work, and it allows you to just focus on that 4th item that doesn't work and has you to get to the finish line a lot more easier as well. Now, coming back. So what is the new learning that we have while doing the demo? Specificity of instructions. Like we said, rather than saying help add entries, you're being specific. Add a button, you're saying what should that button do? What should its functionality behave like? And this control allows for the system to give you exactly what you asked for. So recall that there was something called as the context window. Remember the fact that it is trained on a large corpus of data. And the greater the context that you give and the more specific it is, the tool actually understands and appreciates you to create the outcome that you want, rather than giving it an open shot and saying, build everything for me, right? There are other benefits as well, right? One is you start understanding what actually goes into building any software products. Rather than treating as some black box, it allows for you to get a sense of work. How does your product actually work? In case you build something, how do you know that it's actually doing what you wanted it to do and not doing some crazy behavior that you didn't expect for it, right? Because as you can see, if I ask it to do X, it sometimes does X plus Y plus Z if I'm not specific about it. And the off chance that Z and Y are counterproductive to you, sometimes it could be security issues, sometimes it could create a functionality that you didn't intend for, somebody could discover and could exploit your system. It does then matter that when you ask for X, you get X. It also unlocks the power of zero shotting and few shotting. For example, once you become a little more comfortable with zero shotting and few shotting and doing this activity, you also know what is actually coming out in that few shot version. You know what to extent it works, what extent it doesn't work, and you can specifically narrow down into that one or two elements that doesn't work and actually get it to the finish line a lot more effectively as well. So I'm not saying don't do zero shotting, but once you learn this, your ability to do zero shotting also gets a lot better because you're able to go down to identifying what doesn't work the way it should work and specifically target that. Now, I'm not going to try to do this as a theory. I'm going to again give you an example of what that is. So coming back to a real world demo. Sorry. Is my screen visible? Great. So how many of you have played this game called Wordle? Awesome. Okay, only one person. Okay, few more people. Great. Good to know that it's a popular game, right? So if you notice, I started off by trying to zero shot the game, right? Saying I make a Wordle clone. It did a reasonably good job. It came out. And then I said, build out the full functionality. And then it started getting stuck in a loop. It started checking for the code ways. And then it identified that ultimately it needs a list of words in order for it to function. And then it got stuck in this infinite loop, didn't debug. And finally, I had to kill the process. It spent an inordinate amount of time and also sunk a huge amount of tokens in this process. But if you have understood Wordle, what you would have done, and as you practice and get better at it, you probably don't have to write out. You intrinsically know what are the components of making a product like Wordle. You realize that in a game like Wordle, there are, again, three components, right? There's the UI component, there's a core game logic, and then there is a data or an API requirement. So before I show you how we go about doing this, take a, again, step-by-step approach to saying that what are the UI components required for a game like Wordle? What is the core logic for a game like Wordle? And what could be data requirements for a game like Wordle? Now, feel free to use the chat, or if you want to also raise your hand, I'll and unmute yourself. I'll let you know. Either ways work. So what goes into Wordle? What are the UI components? I want this to be very specific. Think about for a moment that you're actually talking to an engineer. Imagine the Wordle game. Otherwise, open up Wordle on your phone. I could do that as well. Let's do one thing. Let's actually open up Wordle. Look at the screen and let's think through what are the components in this. What are the UI components? What is the game logic? And what is the data? Feel free to use the chat. All right, fields to input of letters. All right, what else? All the alphabets with enter and delete button. All right, what else? Ability to define a valid word, validation file letter showing the right letter based on match. All right. QWERTY keypad. All right. What else? Input elements, display elements of alphabets. Good. This is a good start. We're doing much better than the expense tracker version. Now coming back here, right? So here's what a good V1 of a basic Wordle game consists of. A 6x5 letter grid, keyboard to click the letters. You'd want to show the wrong letter color. So in case the letter is not there in the secret word, there should be a way to represent that. The right letter in the wrong position, the right letter in the right position. All of these are the UI components to show feedback to the user, whether or not they're giving the right input and the output is according to it. Then the logic. First, you need to have the ability to input the letters in the first place, either via a keypad or by clicking on the screen. Next, you want some logic to do the letter check, matching whether the letter exists in the word in itself, and the position check as well. And for the match and the position, you have the corresponding color to show in the UI. Then you'd want to show the game state, whether the user has won the game, lost the game after 6 tries. And if the user has done 6 tries, then the word should show up saying that you have not guessed the word. And if the word is guessed correct, then there should be some kind of feedback which says that the user has won the game. And lastly, you need to have an exhaustive list of all the valid 5-letter English words in the English dictionary. The entire premise of this game is these 5-letter words. And if you don't have them, you can have all the fancy UI, you can have all the logic, etc. But if I enter a word and a very valid word at that, and the system doesn't recognize it, think about it as an end user. I'll be like, hey, this is a valid word. It doesn't accept it. So there's something wrong with this game. So you need to understand all of these elements. So that's why we, again, get into the nitty-gritties of writing down this data. And why this matters is when I actually try to zero shot or few shot it, it becomes easier. So now let's actually do that. I should go to, no. Yeah. Make a Wordle clone. Cool. It has embarked on its journey to build a clone for us. Question, what is the best approach, inputting all the valid words down or using an API to determine the word validity? You can do both approaches. It really boils down to how familiar and comfortable you are with either approaches, right? You can do both within your scope as well right now. For the sake of this exercise, we'll probably just upload a text file which consists of all the valid 5-letter English words. But at some point, if you want to use an API as well, not a problem. You can do that. Both approaches work in this case. All right, let's give it a little bit more time. Rohan's asking a question, is meta prompting effective? I use ChatGPT to refine my prompts for clarity, conciseness, and token efficiency before sending them to Replit, or is that worth doing? I mean, sure, you could try it. I personally find that having my own clarity on how to be specific and practicing it gets me to greater outcomes. What I do sometimes use ChatGPT is to mostly get a sense of complexity to know that, hey, is this even in my realm of comfort and feasibility, or am I overstepping boundaries at this point of time? But sure, if you'd like to try it, I would highly recommend you to give it a shot and see if it gets better. I can't guarantee and say that it will result in token efficiency, because token efficiency is not per se controlled by what you're giving as input beyond the specificity. If it decides to add more features, etc., then yes. But usually being more specific about what you want and saying what you don't want, or putting hard inputs saying, do not build anything more than I asked for. Those kind of statements act as a guardrail to prevent the system from going on and building extra 10 other capabilities. And that's where your token burns as well. The other areas where it burns is there are certain modes of building, let's say in tools like Replit. So for example, if you notice in Replit, there were two things, build a functional version and do a design version, right? I usually find it that take the design version and keep iterating upon it is cheaper, faster than asking it to build a fully functional app, because the fully functional app ends up sometimes being more clunky and like really burns through tokens. And I think this is a PM at work. They're trying to optimize for monetization. So I would rather take the design version and then personally fine tune it to my end state and just push it out there and keep working. So that kind of gives you greater control on outcomes and cost as well. Cool. There's a lot of now flashy signs that are going on. Good. It's showing some progress, but we'll have to see finally what turns out. So this is taking time. So I have another version that, okay, okay, it's still taking a little bit of time. Let me, cool. It's kind of ready. Keep iterating. So now let's see whether it works. So given this UI, ideally, if we were to enter inputs, it should start showing feedback to us. So let's type in. So now, as you see, it still is being a little clunky. We asked it to enter audio, but rather than displaying the words here, it kind of blanks out. And then it does say that the word A and D is there, but it doesn't fix. So at least now you know that given the specifications, that the ideal behavior should be that the letters should be displayed. So you would probably want to give feedback to that for saying that the first input-output mechanism in itself is not working, right? So having a sense of how the system should work gives you the ability to immediately test and see the functionality. Is it as per expectation? Is it off? In a few other versions, for example, it actually comes to giving a reasonably good working model. But what it doesn't solve for is the word list. So you'll have to manually upload. So these are all the kind of variations that you can play around with and realize how you can start with zero shotting, but having that prerequisite list allows for us to then modify specific parts that don't work and then make the optimizations. I have another demo to show. So in the interest of time, I'm going to start moving forward to that as well, right? So as you can see, writing requirements is good. It helps us in debugging and also then taking care of going towards those zero-shot problems and also then optimizing those to make it work. So now, what will seem like a good complex problem? We did first a form, an expense tracker. Then we did a little bit of optimization on Wordle. Now let's make a slightly more complex app, and we'll go to a slightly new, different environment so that there's a little bit of change. And for that, what we're going to be doing is we're going to be building Perplexity's Comet browser assistant. So how many of you have used Perplexity, especially Comet? Awesome. So one of the cool capabilities that Comet has is that it has an assistant, and anytime you have, let's say, a web page that you're looking at, etc., you can have conversations with that web page. You can summarize that page. So we're actually going to build that. And to build that, before we again go into building, I'm going to again force you to go through the exercise of thinking through and telling me what are the UI components, the logic component, and the data component. Again, the reason why I'm asking you to go through this repeated practice is you're getting into the habit of thinking in components and understanding its functionality, because now you have Perplexity Comet browser, you've seen it, but it's very unlikely that this code is open source. It's out there in the open for it to replicate. So now you need to really know how to reverse engineer this product, or you at least need to know the fundamental building blocks to even replicate something of this nature. And for that reason, I picked this, right, to show you how much freedom you get by understanding the fundamentals. So now look at this for a moment. And yes, there are a lot of elements in it. Think for a moment, what is the simplest version? I'll just give you one clue. We're going to do this in Google Chrome. Chrome has the ability to do a lot of modifications in its system and build custom applications on top of it in itself. So it's an interesting environment in itself. So given that we're going to use Google Chrome, I want you to think for a moment, look at this and tell me, what do you think are the components required for you to build the equivalent of a reasonably, like it should almost come close to a Comet browser's assistant. So we may not necessarily get to the finesse and polish of how the assistant looks on Comet, but it at least kind of gets close to replicating its functionality. So what do you think are the components required? Feel free to type it down in the chat. Web view and plugin, all right. What else? UI, a field to give instructions, button to submit, great. Access to model with summary-like functionality, awesome. One layout, only text, or the user to read, one layout to input, all right. Great. So now I'm going to show you what it actually consists of, right? So if you really want to pull this off, let's start with the UI. You first need to have some kind of a UI to support the side panel in Chrome, right? Now, assuming that I've never, ever gone on to building a Chrome extension or playing around with Chrome environment, probably the hardest part for me is to figure out how do I even get the side panel to be created in Chrome. And then once I've achieved that, I have to figure out how do I put a chat interface into that. Once that UI problem is solved, then I can say, okay, how do I extract text from the website? That's the harder part, right? See, once you have this, there has to be some system that is able to understand what the active page is, extract the text from the website, then pass all of that text along with a prompt to OpenAI, and then finally display that summary. And for the purpose of this exercise, we have to use OpenAI's API as well, because that's what's going to do the data transformation activity for us. So this is what are the basic building blocks of building an assistant like Perplexity's Comet browser's assistant. So to do that, what we're going to do is now move to a newer tool. So we've thus far seen Lovable, we've seen a little bit of Replit. Now I'm going to show it how we're going to do this with Claude. Now the reason why I'm picking Claude is Replit is great when it comes to building web applications. Now we're moving to a completely different environment, the Chrome browser. And therefore, for that particular environment, I need code to be generated, which can be directly injected into the Chrome world. So one of the things is Chrome supports a capability called as extensions. You can write code, and you can use that code to perform a wide range of operations within the browser. So you kind of have like a mini app store of sorts. How do you figure out when to use Replit and Claude? Great question. So whenever you're building simple web applications, if that's the universe you want to solve for, Replit is great. If you want to get into writing raw code for different kinds of environments and environments for which the deployment environment is different, Claude is then universal in nature. A very specific version of that is Cursor. Cursor allows you to integrate with GitHub, which allows you to then push to both web applications as well as mobile applications. Claude is more free-form. It gives you raw code, but working code that you can put into web applications, to Chrome extensions, into mobile applications. All of this can be done, right? But Claude lacks the ability to integrate in some of these use cases. Cursor has some integrations. So Cursor works directly well with mobile. So if you prompt, if you do a set of setup processes, you can directly write code, you can write instructions into Claude. It automatically sends it to your system. From your system, it gets read into, let's say, your Android Studio or your iOS Studio. And that loop is easier. Claude is slightly more difficult for it to do. But in the case of Chrome extension, because it gives really good working code, I directly prefer to use Claude. So largely your target environment kind of helps decide which of these tools you'd want to do. Right now, I would say don't get too caught up with these things. Just focus on Replit, Lovable, etc. Just get comfortable in that environment in itself, especially if you've never done any form of white coding. Once you've exhausted that universe, then you can start thinking of going to Claude and Cursor, etc. So for a moment, don't go too far into that world yet. But the purpose here is to show you the kind of freedom that you can get when you start using a tool like Claude. So now I'm going to go to Claude. And what I'm going to do is I'm going to start by saying that, listen, I've never built a Chrome extension. Or even if I have, I don't know specifically if the side panel is something that I can achieve. So I want to first solve for that problem statement. So what I'm going to do is ask Claude, make a Google Chrome extension that has a side panel and displays hello world. So you can see hello world is like my safety zone, right? Anytime I start, I always start out of the hello world to just make sure that, okay, I'm getting the basics right. It works before adding on more complexity. Now, one of the interesting things also with Claude that you can see, is the speed at which you can actually iterate becomes faster. It writes code faster, and it allows for a lot of certain types of problem statements to be quickly validated. With Replit, took a fairly long time. As you can see now, code is almost ready for us. Remove items from. Cool. So now what I have is two codes. Now I need a way for Chrome to read this. So I'm going to bring in another friend here. So this is a simple text editor. What I'm going to do is, I don't even know what this code is, right? For me, it's still a black box. I'm going to treat it that way. I'm just going to do the simple act of copying it. File, save as, documents, Chrome extensions, create a new folder. That. Site unpublished. Awesome. Now we got the basic code in place. Now what we're going to do is load this code up. Hello world side panel, it's ready here. So now we go here, add it. And it doesn't work. So great. Now we have some debugging to do. And there we go. So now we have the side panel working. So at least now I know that I can create the side panel, and it looks just like how the Comet browser assistant works. Now that this shell is set in place, what I want to do now is at least create a basic chat interface. At least we'll overcome the UI hurdles before we get to the logic part of it, right? So what we'll do is we'll go back to Claude and say, now, instead of displaying hello world, create a simple chat interface. Follow the material design guidelines. So what we're going to do in the meantime until that happens is we're going to create a clone of this. And this is how we are doing a little bit of version controlling. So in the off chance that something does go wrong, we can always roll back to the earlier version. So now we go to, but instead, save as. Replace, yes. Thanks. No. There we go. Now we have a chat window ready. So now we've got the front end, we've got it embedded into it. Now comes the slightly tricky part, right? We're now going into a little bit of an unknown territory. We actually want to make this chatbot have a conversation with OpenAI. So now for that, one, we need to have an API. Second, we need to have an API key. And third, we need to tell Claude that we want to be able to have a conversation with OpenAI. So for that, we're going to give the instructions. Great. Now we unload this. Awesome. Now we have an input which asks for OpenAI key. Now we will give it our key. So one of the things that you'll notice is as you start going towards slightly more non-replit environments, the key skills you'll have to learn is knowing where error logs are going to be shown and knowing how to take that and give it as feedback. So for example, while we were building this, we got an error which says that there is a security policy on Google, which doesn't allow for some kind of code to be written. So now when you give this feedback to Claude, it'll make the changes accordingly, and then it'll start working for us, right? So as you start going towards some of these applications, it also then becomes a skill to start learning about where are your error logs going to show up, how do you keep a track of those error logs, and how do you take those error logs and put this in. Don't we have to version control this? Ideally, we should, but in the interest and paucity of time, I'm actually rushing through, and I've done this a couple of times, so I can figure out how to get this to work at this point of time. Cool. Now let us. All right. Why don't you folks give me a question that we can ask OpenAI? Yes, Anirudh. What is the question that we'll ask OpenAI?
Any random question, right, Deepak?
Yeah, any random question. My
What is the
intelligence is
best
not
time?
at risk right now.
Sure. So, what is the best time to visit Japan?
That's right. Sure. There we go. So now we've got the API working. We're making a call, we got a request, the answer has come in. Now comes the interesting part. We need to open up a website, make it read content, and summarize it for us. That's what your Comet browser extension does, right? So let's go to this page. So now ideally we want this page to be summarized. Now comes the hard challenge. How do we get this from here, behind the scenes, to OpenAI, and for the answer to come back? So again, now the interesting aspect to this is as you start going into newer territories, you also have to start learning a little bit about tech. What this does is it allows you to truly unlock capabilities. Now, for example, if you did not know that this web page could be scraped, and there is a mechanism to do this, you would never be able to go about even exploring this opportunity, right? So as much as vibe coding is cool, if you stay away from understanding some tech systems, how does a website work? What are all the various kinds of capabilities, abilities out there in the internet, and not being up to date about it? What it does is it actually truly limits your creative potential, right? For example, if you did not know that you can access Apple Health Kit SDK, you would never even think about being an AI health coach. So vibe coding will not solve for that. This is a problem of our curiosity and creativity. So we need to be starting to get curious. Now that you have the superpower in your hand, you need to start reading up. So for example, if you ever look at a product out there in the wild, for example, when you see Comet's browser and it does a summarization, an important activity for you to be doing at that point of time is not just going, wow, there's a great product, but now that you have a tool like, say, Replit, Cursor, Claude, etc., just go and ask, hey, like, what goes on behind the scenes? How does this actually work? What are the various components, right? And it's not that on day one you'll get an understanding of everything, but as you keep doing this over a period of time, the dots will start connecting and you'll be like, I can actually do this. Like, I know that it's possible for me to scrape a website, and therefore I can try actually replicating Comet's browser extension by myself, and it's doable because these technologies has existed. I understand what the components, how they relate with each other. So in order for you to truly unlock your creativity, it does first become important to not just use products, but starting to appreciate what could be going on behind the scene, doing a little bit of research, use tools like ChatGPT, Claude, Gemini, etc., and ask questions. How does this product work? Keep doing this repeatedly and say, explain like I'm a 5-year-old, right? Then say, explain this like a 10-year-old. Okay, explain this if I were to wipe code and build this by myself and make these components easy for me to understand. So when you do this exercise, you'll start being able to appreciate what are all the things that are possible that were otherwise not doable before. And suddenly the canvas becomes a lot wider. So now you will not just think, oh, let me make a simple Google form or something. Your creativity level starts increasing. Now, coming back to this, if I were to scrape this, the first thing I need to know is it's, first of all, doable to scrape. And second of all, I need to know that there is means to do this. Now, one interesting way to achieve this problem is a lot of problems, or at least a reasonable number of problems on the internet have been solved well. And thanks to platforms like GitHub, Stack Overflow, the code exists. So now what we're going to do is we're going to go to Mozilla, and they actually have the code ready-made available for us to just do the plain vanilla text extraction. So we're going to leverage this third-party library to solve this problem. So this is the cool thing, right? Once you know about this, suddenly what you can do with this is a lot more powerful, right? If I did not know this, I wouldn't be able to do this. So now I'm going to just take Mozilla's code base. And now I'm going to tell to Chrome, I want to summarize the active page I am on in my Google Chrome browser. Extract only the text elements from the DOM. Use the following like the extracted text should be passed along with a prompt to summarize with AI API. Cool. Let's see what happens now. So as you can see, we've been able to actually get to a reasonably faster version of a product by using the raw code version as opposed to Replit. But you'll get here after a little bit of practice. Could we have still instructed Cloud to write code scraping without mentioning the library or asking it to find the library? You can do it. Uh, Chances are there are many, many libraries. It would randomly pick one. I would rather do a little bit of research by myself and have the freedom to try out different libraries and find out which ones work best. So if you give Claude the freedom, it doesn't per se know which is the best library or which should it use. So it can go with any one, and that may result in poor outcomes. Rather, make it modular so that you can keep trying different libraries. So come to a version where you reach the stage where you don't have to add the libraries. Then you create different versions and say try library 1, library 2, library 3, so on and so forth, and find the library which actually does the job for you really well. And once you've identified that, that becomes your standard code. So again, try to have a little bit of control and do a little bit of research to find out what works. Otherwise, if you try to let everything to be determined with code, chances are that sometimes, again, because it's probabilistic, sometimes you'll be lucky. You will get the right libraries, things will work out. But it's better that you do your own research. So sometimes I find it more effective to, let's say, go to ChatGPT, do a little bit of research, say what are all the open source libraries out there, which have the best star ratings, go review it, see if it's popular, well used. Then pick one. It's cheaper, faster, and more effective than hoping to just stumble upon a library that works for you. And this is true for any kind of library function at the end of the day. And now, alrighty, fingers crossed. Let's see how this works now. There you go. So this is a more condensed version, but you see the essence of it. The text has been extracted. It understands the page correctly. So it has identified the web page to be YouTube tip of the Google sphere. And then it goes into the details saying, hey, this article discusses about NVIDIA's significant investments in OpenAI, yada, yada. And you can see this is a concise version. If you want to modify it and you want to make it more elaborate, I'll just show you that piece as well. So somewhere in this is the code which governs how to generate the output, right? So if you notice, this is the model that is being used, and this is the prompt that is being used. So in order for us to get to the same degree of verbosity that Comet browser has, what we're going to do is two things. One, we're going to change the model, and second, we're going to modify the prompt a little. Cool. Now let's see if we're able to get a better outcome. So now let's try summarizing this. The reason why this is happening is because we have not updated the code yet. So what we're going to do is go to Manage Extensions, reload. Now, as you can see now, the summary has become a lot more detailed. So it identifies. So this is probably like a 10-minute read. This has still identified all the key elements, but make sure that you can probably consume this in about a minute or two. You want to make this fun, you can connect this to OpenAI's text-to-speech, and you can have this read it out to you as well. So as you can see, as you start gaining control, going step by step, learning how to debug, the opportunities for you to build things kind of dramatically increases. And learning about tech, being curious about how various kind of products work, and probably using tools like ChatGPT, Gemini, Claude, etc., to help you break it down into simpler pieces and say, what are the pieces inside it? How do they work? What goes on? You can then start appreciating what is going on, and then you can start connecting the dots, and then your creativity suddenly starts unlocking, because then you can say, oh, if this can be done, and there's a piece of technology that can do this, what if I connect A and B together? So then your creativity is like just off the charts there. Then you're not just limited saying, make another expense tracker, make another Wordle clone. You can do more than that. You can make your own games, you can make your own applications, and then at some point integrate payments, put it on mobile, and even push it out to the world. And who knows, maybe the next millionaire, billionaire is somewhere sitting in this group right now, waiting to wipe code their startup. So that brings us to the end. So key summaries here, right? So again, I'm going to highlight the most important ones. Most internet software can be simplified to 4 components: the UI, the logic, the database, and API. Just remember these 4 things, right? This really, really helps you to simplify and identify what goes into each of these blocks and what should each of these things do. Second, if you're non-technical, the code is a black box, right? So you are limited by the context window. But again, because of that context window, it also opens up opportunities. There are many more things you can do without being too worried about that window, right? Recall that vibe coding gives you different outputs for the same input. Some of you ask, but hey, I've heard that OpenAI has this concept called as temperature. If it brings down to zero, will it not become deterministic? That is true when you're accessing API models, when you're using agents for coding. Largely, the companies control the temperature. So you don't have an absolute control over it. So the only way for you to control and get it close to being deterministic is actually being very, very, very specific with the kind of instructions that you give. Zero shotting is definitely fun. You should do it. Not saying don't do it. But understand that if you just keep doing that, it kind of limits you on the long run. Rather, learn how to break down problems, be specific about requirements, give those requirements, build step by step. Vibe coding is easy. Debugging is the difficult part. And building things step by step is actually what gives you the power and control to go wide, go deep, and get to the kind of precise outcomes that you want, right? And be specific about the instructions that you want at the end of the day. Lastly, keep practicing and exploring. There's no way on earth that you can just wake up one fine day and start building, the things that you desire. Rather, treat this as a journey of 100 or 1,000 steps. Keep doing small things every single day. Set aside time. Like in the early days, I actually used to use my cab rides for vibe coding. So I would, let's say I have a 10-minute ride out. I installed Replit on my phone and I'd say, okay, goal for me. In 10 minutes, I'm going to get something to work by the time I land at my destination. Something that I found to be a lot more fun than listening to podcasts over a period of time. So find out small avenues in life where every single day you can practice tiny pieces of vibe coding, experiment, look at an app, try to replicate it, use ChatGPT for guidance, etc. But you will not reach that perfection on day one. And don't let your ego get in the way of saying, I want to build the most magical enterprise level problem statement on day one. You're setting yourself up for failure. Start small, build confidence and complexity. And eventually, someday, you'll be able to outgrow and maybe you'll get curious enough to learn programming as well. And then you can go on to building those complexities. So with that, I'm not going to say this is the end, but rather welcome to the epic world of vibe coding. For all of you who stuck around till this one of time, a big round of applause. For spending more than about 2.5 hours on a lovely Saturday. There are so many other things you could be doing, but instead you chose to be here. And I hope you have learned something meaningful, useful. The reason why I put this out was there are a lot of videos out there on YouTube. There's a lot of hype about what it can do, but I felt that, sometimes I feel very dumb as a person. So I find things just going over my head. I'm like, but that just doesn't make sense, like simplify it. So I wish someone had done this for me. So I'm kind of doing this for myself at this point of time because it helps me stay grounded as well when I think about it. And there are a lot of folks who reached out saying that, hey, how do we cross this hurdle? So I thought I'd put it out there for you folks. And in case you are very excited and you want to go to the next level, I am having another session starting October 4th to 19th. Where it's a more longer, intense 3-week session where we'll be actually vibe coding about 9+ web plus mobile products. What it does is we'll cover through all of those 17 steps that I spoke about. So every Saturday for 4 hours, every Sunday for 4 hours. Rather than me demoing it to you, I will ask you to do it. So I will be a terrible human being. I'm going to force you to write code, review it, do it step by step, force you to go through all of these steps, and gradually till you build confidence to even going about building mobile apps, integrating payments, putting analytics, solving for search, etc., putting it out there on a web application, sharing it with your friends. And finally, towards the very end, there's going to be about 4 hours where you're going to be showcasing me how cool you are. You can pick any problem under the sun, and you have to build in 4 hours and show me what kind of a product that you can build. So it's about 3 weeks. We'll do this intensely. And this is for folks who really want to push the level. And if you feel that, I want to try hands-on, I would like someone to be there alongside with me to do this activity, to help debug alongside. And to go into more complex problem statements, like say work on Android, payments, notifications, accessing SDKs, etc. So if you want to really accelerate, I have this. But with this in itself, this is a good starting point for you. So with that, we come to an end. And yes, this entire website was also vibe coded. This is done using Cursor, not with Replit. So you actually can do some of these really cool, highly polished kind of website as well. And you can eventually get that. I have reached here after probably about 8 months. So I'm just kind of setting a realistic expectation. You don't land up here on day one. It took quite some time to land here. Many, many mistakes. And I hope that by teaching you this, you folks can compress the timeline. And I'm also doing this as selfish intensive. If you build beautiful products make my life easier. So I'm hoping that some of you build some really nice, beautiful products that solve my problem. So I'm outsourcing my problems to you in this process as well. So with that, we come to the end of the session, and I will open up the floor for question and answers. So yeah, now is a good time. You can actually unmute your. So it starts on October 4th. It's a Saturday, so all courses are on Saturdays and Sundays. While they are designed for about 4 hours per day, usually my goal is to say that until everyone completes, we don't leave the room. So sometimes my 4-hour sessions do end up becoming 6 hours. So do plan for an extra 2 hours buffer to make sure that we can get through. Because one of the unknowns is, see, everyone's system is different. And therefore, there are chances that things don't always work out the way I anticipate. So it does require some time to sit and help you debug and get through. But the goal is to make sure that you do complete those exercises. Are the workshop sessions free? No, they are paid because it does take a lot of my time to be spending about 8 hours per weekend to do it. So it's a paid session. So you can see the details. I'll just share the link with you as well in case you're interested. Feel free to continue asking questions and I'll keep taking them up as well. So for those of you interested, I've shared the link as well. You can check it out. What are your other questions? There are, I think, a bunch of questions that came in during the course of the session, which I couldn't actively answer. So I'll take those now, because if I were to answer them, they would have probably broken my flow as well. How much do we need to approximately invest in tool credits for these intense vibe coding sessions? See, usually we'll try to do with 1 month's worth of subscription, but it really depends on the kind of bugs that we encounter. So that is completely not in my control. So I would say, again, we will try to be judicious, but hard to predict. But don't worry, it's not going to be something like you end up with a $500 bill. I also try to be judicious because I have a budget to maintain for doing these activities. So usually we'll try to keep it well under $50. But you do need to get a couple of subscriptions. So you'll definitely need a Claude subscription, a Replit subscription, and a Cursor subscription to do all things really well. Everything else will be free. Sublime Text is free. Android Studio is free. iOS Studio is free. All the other APKs and SDKs, etc., APIs, I will provide. For example, OpenAI, I will provide. Whisper, I will provide. In fact, Whisper, you can get it yourself. There's a free credit on it, up to about 10,000 credits, good enough to do the kind of exercise that we want, right? So where it's a little more difficult for you to get the APIs, SDKs, I will provide like the payment ones. Where it's difficult or it takes time to get OpenAI credits as well, I will get it up and give it to you so you can use it unlimited during the course of the course. But for you to set up, you will at least need Claude, Cursor, and Replit. We'll just stick with these three, and we should be able to do a reasonable degree of containment within that in itself. How can vibe coding be used to be a better PM, and how can we use it to work on product strategy for an existing product? So two things, right? So one of the things that you can do with vibe coding is, rather than writing a one-pager, you can use vibe coding to actually demonstrate the idea that you have in your head. So you can take like images and screenshots of your company's products, etc., and kind of make a rough working demonstrable prototype that you can share with your stakeholders. Easier to play around with and understand. So I think that's one way in which vibe coding really, really helps. But if you're to say, can it be used for product strategy? Sorry, that's a very different problem statement altogether. Vibe coding is a rapid development tool. So if you have an idea, to go from idea to demonstrating it, it really compresses it. But does it help you come up with better strategies? No, that is still a product craft problem statement. You still need to get better at strategy independent of vibe coding. Once you build a website or web app using Replit or these, where do you host it? Replit gives you the opportunity to host it on its own platform. So there is something called as publish. You click it. There's an auto scale functionality. You set it at the bare minimum. You don't need anything more than that. And it works really, really cheap. In fact, at zero cost as well. But the minute you go to, say, Cursor, you need to use tools like Render, where you host. But the beauty of a platform like Render is it has a very, very generous free hosting platform in itself. And one of the cool things is it only spins up when demand comes in, and otherwise it stays off. So it kind of makes it makes it super cheap. So in fact, a lot of my fun projects, I just push it out on Render, and I don't even have to pay for it unless it's for a commercial use case. And I expect it to be up 24/7. So you can use Render absolutely free, and it's free hosting is super generous. Static websites, no questions asked, absolutely free. Even dynamic apps, absolutely free. It just spins up when the traffic comes in. Sure, you probably have to wait for about 10 seconds, but it's totally worth it, man. You don't have to spend money on it at all. How easy or difficult is it to connect with a database? Not really that difficult, but it just takes a little bit of nuance to understand how to connect it and how to ensure that the entries are reflecting in your database, and the database operation, the CRUD operation that I said, right? Create, read, update, delete works really, really well. So once you've understood those basics, it then becomes easier to then go on to building with databases. Again, not too difficult. I would place it somewhere in the intermediate. It's not simple as well, but in the intermediate can be done. It would be extremely helpful if we can have similar sessions once a month if possible. I'll try. It's just a question of time. I have a startup that I run almost 5 to 6 days a week, and then I try to squeeze this in this activity as well. So whenever I do get a little bit of free time, I will try to host these activities. So we'll try my best. Also, when you have to go back and make some changes to go and modify it for a different context, how much work is that? It really depends on the problem statement, right? In most of the vibe coding scenarios, when you're working with Replit, so long as you know what changes need to be done and what functionality needs to be changed, you can just guide the system to do it. Once you start getting a little more hands-on with code and you know where to look in, some of the changes, for example, can be directly done without going to Replit or Cursor, right? For example, if I was to change text, I wouldn't waste my tokens. I would rather go to my Sublime text, know where that text file is, make that quick change, and it's a lot quicker and faster. But if it was a logic change, I would definitely go to Cursor, make those changes. So it is really a function of what you want to change at the end of the day. Any other questions? Between vibe coding versus agentic AI, how do you know the right strike and right balance for your problem statement? If you're a non-tech person, I would say stay far, far away from agentic AI. I think there's a lot more marketing and buzz around it than what it can actually do. And the complexities of actually pulling it off is really, really not so simple and straightforward. Even tools like N8N, as much as they make it sound simple, is incredibly complex, and you don't even need some of those complexities at all for many of the things that you're trying to achieve. So I feel that there's a lot of overkill going on in the world of agentic AI, and in fact, most things are over-engineered and called as agentic AI. Some of these things can be done with simple workflows, if-then-else statements, and traditional if tools like Zapier in itself. Really no need to do an overkill with agentic AI. I think that's more of a marketing BS that's going on at this point of time. So there's a lot that you can unlock with vibe coding. Would be a little wary of going towards agentic AI, especially if you don't have a little bit of a technical background. It really puts you at a disadvantage than at an advantage at this point of time. Cool. Any other questions?
Deepak, just wanted to clarify on that, right? On the same point. But are there scenarios that you would really believe that agentic AI would be the right solve? So I am a product manager and I come from a tech background myself. So
Right.
Are there questions or are there problem statements where you do believe that no, agentic AI might be the right solve than just sticking to vibe coding?
It depends on the nature of the problem, right? But it's not as easy as it sounds in terms of, let's say, you prototyping it. Even in companies where they have really good engineers and they try to build agentic systems, it actually has a lot of complexity. And one of the most underappreciated factors of building an agentic system is this entire fundamental is on probabilistic systems. And let's assume that a step one agent has 80% chance of getting something right. If you chain it with another agentic system, then the probability of that succeeding again is another 80%. So net, if there's a two-step function, by the time it's been completed, 45% to 50% of the time the system is failing. Now you have to ask yourself, is it then worth having a system where it fails 50% of the time? And what extra benefit are you getting in this? So I would, as much as possible, try to make systems really, really deterministic and try to avoid the number of function call, tool calls, etc. It sounds great in theory, but getting it right is an incredibly complex process statement. And if you're trying to do it by yourself, I would really avoid getting into those kind of complexities.
Understood.
If you have an engineering team, well, then you can pass on the buck to them and saying, I need it as a product manager, get it built. But then the discernment in being a good product manager that I sort of say is, what is the nature of this problem? Why does it really require an independent investigation by an agentic system? What about it is non-deterministic in nature? What requires a lot of explore, exploit? If an explore, exploit, why can't another simplistic machine learning model do it? Why does it have to go on this exploratory activity which reduces the odds of success? Right? So I would really, really try to break down the problem statement and understand where is that benefit and try to really, really minimize the need for function calling as much as possible.
Got it. Got it. Got it. Thanks.
Because
Thanks.
technically, agentic AI is function calling. That's a simple way.
Yeah. Got it. Yeah.
Minimize your need for probabilistic function calling and try to make it more deterministic.
Yep. That helps. Thanks, Deepak.
Awesome. Any other questions? What is your opinion on emergent? I have friends working there, so I try to be politically correct. It's interesting. I find it difficult to use it. I put it on me and not emergent. I've found it difficult to get to outcomes with emergent. Any learnings on how to prevent vibe coding tool from hallucinating? See, hallucinating is it's a feature, not a bug. So the way to solve for that is actually being very, very methodical, stepwise, giving the right kind of instructions and controlling its drift. That's the only way you get closer to being deterministic or closer to the outcomes that you want. You really, really can't stop hallucinating. It's a capability, a feature, not a bug. Any other questions? Cool, awesome. If there are no other questions, thank you all for taking your time out on a lovely Saturday and investing time. Hope to see some of you going on and building some very interesting products. And if you do build something, do share it with me. And if some of you are interested in joining for a 3-week bootcamp next week, do ping me as well. Happy to catch up and share more details. But with that, thank you so much and have fun vibe coding and welcome to a very interesting, fun world. And hope to see many of you build some very fun products along the way. So thank you, and have a lovely Saturday. And hope some of you get to starting to build something immediately fun and interesting. Awesome. Yes, like I said, Abul, I will try my best to have some fun sessions free. But thank you all. Have fun. Take care.